It's a popular opinion these days that climate change is a serious problem. There are lots of ways to go about replacing fossil fuel power, with a lot of focus on renewable energy. But there was a time when nuclear energy was thought to be the future, and maybe it still is. In this video, we'll look at how nuclear energy is used to produce power and weigh the pros and cons. Let's begin with how we produce energy with the power of the atom. We all know from chemistry class that atoms are, at the basic level, made up of a nucleus that contains protons and neutrons, with electrons orbiting the nucleus. That's a very simple model of the atom, but it'll do for understanding the process of nuclear fission. Fission is the sciencey term for breaking things, and that's basically what we do in a nuclear fission reactor. The fuel for a typical reactor is going to be loads and loads of uranium rods dipped into a vat of water. After a chain reaction is started, neutrons from one rod will smash into the atoms of other rods, breaking them up and firing off their neutrons. The thing is, the forces that hold neutrons, protons, and electrons are really strong. So when these bonds are broken, a tremendous amount of heat is released. That heat is used to boil the water in the vat, and that steam is sent along channels to drive turbines. Steam-powered turbines are a really old innovation that forms the final step in basically every power generation system. The force of the steam can spin the turbines, thus producing electricity. All this is done without the release of any carbon dioxide or monoxide or methane or any of the other stuff we know is wrecking our atmosphere. The only dangerous byproduct of this process is nuclear radiation, which is carefully contained in the facility. Sounds pretty good, right? We'll start with the biggest advantage of nuclear energy, the output. In the current climate mitigation discourse, renewable energy sources are seen as the way forward. But no matter which renewable energy method you consider, they all have the same problem. They're pretty weak in producing energy on their own. Solar, wind, and hydropower just don't give you the power that you need to run a city, and they're situational too. A nuclear power plant, though, can handily replace a coal-powered plant. In fact, some nuclear power plants can actually produce more power than an equivalently sized fossil fuel plant. You don't have to engineer a careful combination of renewable energy sources when a handful of nuclear plants can do the trick. You can also future-proof your power grid much better with the increased power output of a nuclear plant. The future is electric after all, and the world will need a lot more clean electricity in the years to come. Another benefit to the potential output of nuclear plants is that they can be deployed a lot quicker than renewable energy, and climate disasters are mere decades in the future, with some serious catastrophes rocking the world in this very year. Do we have time to figure out how to implement a renewable power grid? Probably not, but nuclear power can be a much faster substitute that still keeps the world turning, the way it has been all along. Another advantage of nuclear power plants is that you can basically put them anywhere, while solar power plants can basically be anywhere there's an open sky. Things get more complicated with wind and hydropower. You obviously need fast-flowing bodies of water to build dams on, which not every country may have. But with wind farms, the task is even trickier. You can't just build a wind farm anywhere. The government has to carry out a meteorological survey to find out the best places to expose a wind farm to lots of wind. This can lead to lots of problems. How do you transmit power to areas that are far from your farms? And what if those optimal wind locations happen to be on private property? What if the owners of the property would rather the world burn than let any outsider build on it? Nuclear plants don't have to deal with these problems because you can build them basically anywhere. The only conditions you need to fulfill are making sure that trucks can transport nuclear fuel to the plant and keeping the plant far away from population centers. But you know what? Those are the same considerations that go into building fossil fuel plants. This is yet another example of how nuclear plants can cleanly replace fossil fuel plants. The more we talk about this, the more it seems like a no-brainer. But we know that a lot of y'all would disagree. That brings us to the cons of nuclear plants. The first one is safety risks. In 1986, the people of the Soviet Union discovered just how an RBMK reactor exploded. All it takes is cost-cutting in the design and having unqualified people run a dangerous test on one. But for many people around the world, the explosion of reactor number 4 at the Chernobyl nuclear power plant was essentially the death of the nuclear energy dream. Despite the advancements in nuclear reactor safety, a large percentage of people aren't convinced of the safety of nuclear power plants. Those people were proven right when 25 years after Chernobyl, the Fukushima nuclear plant in Japan melted down. And these aren't just freak incidents that you can brush off. The sites of Chernobyl and Fukushima are dangerously radioactive to this day. In fact, you might remember the headlines from Russia's war in Ukraine, where they were concerned that the fighting might damage the actual sarcophagus they built over the Chernobyl remains. Someday those sites will become safe again. But these are risks that many reasonable people aren't willing to take. Of course, if you compare these dangers to literally any other type of power plant, nuclear stands out even today. It's because of these concerns and more that nuclear plants have been shut down in many countries under public pressure. The next con we'll look at is nuclear waste. Even if nuclear plants don't explode like nuclear bombs, the waste they generate is a ticking time bomb itself. The waste that comes from most nuclear plants is largely made up of spent fuel rods. These are the rods that can't produce enough energy to run the steam turbines, but are still radioactive. But every facility in the world produces waste. It's just that nuclear waste has the added seasoning of gamma radiation. Because the waste is radioactive, scientists and engineers and governments have tried to come up with an effective long-term solution for disposing of it. You can't just throw radioactive materials into a landfill after all. Low-level radioactive waste is relatively easy to dispose of, and it makes up 90% of the waste generated at plants. High-level waste is a real problem. At the moment, the best solution that anyone has come up with is to store them at the plant itself until the radioactivity decreases to lower levels, and then store them underwater or underground. There's an obvious problem with underwater storage. Our aquatic life did nothing to deserve our awful radiation. Doing this is kind of the opposite of the environmental conservation goals of nuclear energy in the first place. Underground storage is safer if you can keep the radiation from contaminating the soil and groundwater. The only way to manage that is to build vaults with thick concrete walls. This isn't impossible, and some countries have built a few of these, but it's expensive, and they'll need more of them as time goes on. At last, we come back to the question in the title: is nuclear energy the solution to climate change? When we were looking at the pros of nuclear energy, it was definitely looking like nuclear was the more convenient option compared to renewable energy sources. But here in the end, it sure looks like nuclear power has just as many cons as any other form of energy. In reality, it doesn't have to be one or the other. There's no reason why a country can't have a nuclear plant and other energy sources. And there's no reason why a country can't choose nuclear energy if it's their best option. But we do need to encourage and fund research into nuclear energy generation to solve the waste and safety issues. The holy grail of nuclear power generation is through nuclear fusion. That is pretty much the opposite of nuclear fission, where the subatomic particles are forced to become new atoms. Fusion can create many times more power than fission, and its only waste is water, which isn't really waste at all. We're not there yet, but we've got to push toward it. Whatever your preferred way of producing energy is, it alone cannot be the solution to the world's problems. Fossil fuels are hard to replace, and our new grids will have to incorporate every alternate power source. If that includes nuclear energy, then we have to be okay with that too. That's it for today's video. What are your opinions on nuclear energy? Do you think that the cons are overblown, or that they're good enough reason to leave nuclear energy in the past? Let us know in the comments section below, and don't forget to like, share, and subscribe.